Welcome to This Explainer. Today, we're kicking off a high-stakes engineering audit of the 2026 Toyota Camry. Now, for decades, the Camry has literally been the gold standard of it just works automotive engineering. It's the car you buy and just forget about, right? But with massive, mandatory changes under the hood for this new model year, we really need to look past the shiny marketing. We're tearing this vehicle down to its bare components to see what it is actually made of. So let's dive right into the million-dollar question. Can this brand new generation actually live up to Toyota's legendary, ultra-reliable legacy? Because when you buy a vehicle like this, you aren't just buying it for today, you're buying it for 10 years from now. You want to know if it's going to strand you on the side of the highway or if it's going to sail past the 100,000-mile mark without even breaking a sweat. And well, that is exactly what we are here to figure out. Here is our blueprint for an autopsy of the future. We'll be covering 1. The new hybrid standard. 2. The mechanical skeleton. 3. Engine and drivetrain resilience. 4. The battery and electronic lifespan. And finally, 5. The 10-year verdict. All right, let's get into Section 1, the new hybrid standard, powertrain and thermal upgrades. This mandatory hybrid setup is absolutely the most dramatic shift in the Camry's DNA. We have to contrast the old, naturally aspirated generations against this new architecture to understand exactly what this means for your long-term ownership. In the past, you had a relatively simple gas engine. You turn the key, it runs. But now, the hybrid powertrain isn't just an option, it's mandatory across the board. And this introduces a whole new level of complexity. You've got electric motors working in tandem with the combustion engine, and hey, while that's fantastic for fuel economy, complexity is traditionally the enemy of long-term reliability. We've really got to see how this dual system approach changes the ownership reality over a 10-year timeline. And that brings us to the first line of defense, initial chassis build quality, and some serious thermal management upgrades. Look, a hybrid system generates a massive amount of heat, and heat degrades components faster than almost anything else under the hood. It's relentless. But our initial analysis shows Toyota has implemented specific thermal management upgrades directly aimed at handling this exact problem. They are essentially trying to build a thermal fortress in the engine bay, anticipating a full decade's worth of extreme temperature fluctuations. Moving right along to Section 2, the mechanical skeleton, defending against the elements. We are methodically checking the underbody sealing against a decade of corrosive road salt and evaluating if the front suspension bushings are designed for permanent endurance or inevitable replacement. Listen, if you live in an area with harsh winters, road salt will literally eat a poorly sealed car alive. By inspecting the chassis welds and the factory undercoating, we can see if Toyota cut corners or if they really fortified the frame. Similarly, rubber suspension bushings take an absolute beating over time. Are these robust hydrometer components meant to go the distance, or are they softer materials engineered to fail, requiring a really costly trip to the mechanic at 60,000 miles? So the crucial point as we transition inward is identifying whether high-stress areas rely on durable metal or vulnerable plastic components. Modern manufacturing absolutely loves to use heavy-duty plastics. I mean, it makes sense. It saves weight and improves fuel efficiency. But when you place a plastic component right next to a blistering hot engine block or in an area with constant high vibration, its lifespan drops drastically compared to forged metal. Finding out exactly where Toyota chose plastic over metal tells us a whole lot about their 10-year engineering priorities. Let's peel back the next layer with Section 3, Engine and Drivetrain Resilience, the mechanical heart. By looking really closely at the dismantled 2.5-liter engine head and the cylinder wall coating, we can actually predict the potential for long-term oil consumption issues. When we strip away the block, the microscopic friction surfaces reveal the engine's future. It's like reading tea leaves, but for mechanics. If the cylinder wall coating is robust, those piston rings will seal perfectly for hundreds of thousands of miles.
But if there are weaknesses here, the engine will inevitably start burning oil as it ages, and that is a classic red flag that drastically increases the cost of ownership as you approach years 7 or 8.
Now, I know a lot of people hear the acronym CVT and immediately panic about fragile metal belts slipping or snapping. But Toyota's hybrid eCVT inherently avoids those catastrophic failures. Why? Because it relies on a planetary gear set. There are literally no belts at all, just robust physical gear engagement managing the power between the gas engine and the electric motors. From an engineering standpoint, it is a vastly superior design for extreme longevity. As the car eventually hits this critical 150,000-mile mark, we assessed the accessibility of critical gaskets and sensors to predict just how expensive basic maintenance is going to become. Let's be real for a second. Parts wear out. It's a fact of life. Gaskets will eventually leak, and sensors will eventually fail. The difference between a $100 repair and a $1,000 repair almost always comes down to accessibility. Did the engineers bury a $20 sensor way behind the engine block, requiring a mechanic to pull the entire motor out just to replace it? How Toyota laid out these critical components determines the true financial burden of keeping this car running well past 150,000 miles. Shifting from the mechanical to the electrical, here is Section 4, the battery and electronic lifespan, the brain of the machine. Battery cell degradation is a massive threat, especially if you live in hotter climates. The longevity of this hybrid battery, which, by the way, is one of the most expensive replacement parts on the entire vehicle, relies completely on the efficiency of this fifth-generation cooling system. We really need to see if the fans and ventilation ducts can effectively strip that heat away from the cells. If they can't, you're looking at a massive repair bill down the road. We also tested the shielding on the high-voltage cables to ensure wearing insulation won't become a liability, and we checked if the cabin's software will remain functional or become obsolete. Think about it. You have massive amounts of electricity flowing through those thick orange cables under the car. If that insulation wears down over a decade from road debris or constant vibration, it's a huge safety and functional hazard. And moving inside the cabin, we've got to look at the screens and the software interface. Will this digital ecosystem feel hopelessly outdated, sluggish, or totally unsupported by software updates in 10 years' time? Bringing it all together, we have Section 5, the 10-year verdict, projecting the cost of ownership. But before we give you our final verdict, we have to address the elephant in the room: planned obsolescence. This is the policy of producing consumer goods that rapidly become obsolete and just require replacing. For a brand whose entire identity is built on a run-forever reputation, adopting this modern manufacturing philosophy would be the ultimate betrayal of long-term trust. And honestly, during our teardown, we found specific red flags that could signal exactly that kind of shift. We are looking at components designed as single, sealed units instead of repairable assemblies. What does that mean for you? Well, when a minor internal part breaks, you have to replace the whole expensive module. These are the details that might really surprise loyal enthusiasts who are used to the easy-to-wrench-on generations of the past. It genuinely raises the question of whether maintenance is shifting away from repair and moving straight toward total replacement. So based on the entire teardown, we deliver our final recommendation on whether this mandatory hybrid secures Toyota's legacy or points toward disposable engineering. We've looked at the thermal management, the unyielding planetary gears, the engine cylinder walls, right alongside the complex electronics and those sealed component red flags. It is quite the balancing act between incredible leaps in hybrid efficiency and the creeping reality of highly complex, expensive-to-replace systems. After seeing the bones, the heart, and the brain of the 2026 Camry, the final question is whether you are willing to bet your next 10 years on it. Does the combination of that bulletproof eCVT architecture and the thermal upgrades outweigh the potential headaches of massive electronic complexity and high-voltage aging? Think about your own driveway, your daily commute, and ultimately your wallet. Knowing what's really under the hood, would you trust this new standard for the next decade?